EEG for attention deficit hyperactivity disorders. I'm so excited to learn from Carmen and see what, just learn from her expertise and knowledge. But for those who are interested in CE credits, either Morgan or myself will be dropping that link down in the chat box about quarter of as we approach the close of the hour. So keep a lookout for that. And I believe that's that, but without further ado, I don't want to take up any more time. Here is Carmen.
All right. Hello, everyone. I'm going to go ahead and share my screen. Okay. And then Emily or Morgan, if you can just confirm that you can see my slide. Yes? Great. Okay. All right. Hello, everyone. My name is Carmen. I'm a licensed professional counselor here in Manassas, Virginia at Neurofeedback Therapeutic Solutions, probably about 30 minutes west of Washington, D.C. I've been long fascinated with how the human body functions as a complex machine. And when I say body, that of course includes the brain. That fascination led me to complete a bachelor's degree in biology from George Mason University. And once I got to a master's, well, I had intentions to be a professor of biology, and I did one semester toward that end. And it just really wasn't a good fit for me. And then a little light bulb went off in my mind and said, oh, what about counseling? So I started in a master's program also at George Mason for counseling, and I found it. That was it. I loved counseling. However, the subjectivity of psychology, after a couple semesters, I really found myself craving that objective biological measure that I was so used to from my undergraduate program. And that led me to the Krasnow Institute, where I worked as a research assistant with the Physiological and Behavioral Neuroscience in Juveniles Lab for about 3 years. And so then once I completed my master's, or somewhere along the way, I heard about neurofeedback. I'm pretty sure it was at a conference, probably American Counseling Association or AMCA. And I distinctly remember Eric Beeson and his presentation. I can't remember what it was about. All I know is he was talking about neurofeedback and I needed to know more. And so after a while, I was able to begin working in neurofeedback. And I was already in residency towards becoming fully licensed as a professional counselor. But anyways, I will go on. So today my talk is the role of EEG in the diagnosis and treatment of attention deficit disorders via neurofeedback therapy. All right, so let's see. However, I did not take a class in Zoom. I don't know. Let me see. I did it. Okay, so my first slide is really just about about the prevalence of ADHD. And throughout this presentation, I'm really just going to use ADD and ADHD as interchangeable terms, just because a lot of the research really is on just ADHD. It's not just ADD. And so as I was developing this webinar today, I realized that. So anyways, today, not really necessary to make a distinction between ADD and ADHD. However, we as counselors, psychologists, social workers, neurofeedback therapists, neuroscientists, wherever you may fall, there are significant differences. But for today, the terms are interchangeable. So anyways, we see here that the prevalence of ADHD in the United States has been going up, and up. And this is just some data from the CDC from 1997 to 2022. And really just the different colored plots are just different measures that they used. And for the purposes of our talk today, there's really no need to get into the particulars, but the long and short of it is that ADD is going up. And not only do we see it in the graph I've provided here, but I'm seeing it in my office every day. I would say off the top of my head, 90 to 95% of clients that I'm seeing that are aged 25 and under have some form of attention deficit disorder. And that's pre, during, and post-COVID. But that would be another talk. All right, so I'll go ahead and move on to the next. What is, oh, gotta go back. Okay. What is EEG? Electroencephalogram. So what you see here on the left, this is a typical EEG cap. And basically what you see, like the little holes, those are going to measure from 19 sites or 19 channels all around the areas of the brain to measure the electrical activity that is emanating from each location, as well as one location's activity relative to another. So what happens is we put the cap on, and as you see, the wires come out the back, and those wires go into an amplifier, because if I go like this, I can't exactly feel the electricity emanating from my brain. Like, I can't feel it at all, but it's there. But those signals are so minute and indetectable to us as humans that they have to go to an amplifier. So anyways, they go to the amplifier and then they come to my computer. So down here at the bottom right, what this is a chart with the different brainwave frequencies and their names. And so delta, those are the long, slow, sleepy waves that are really going to be prominent when you're in a deep REM sleep. Then you have theta. Oh, and also the hertz. Hertz is just a measure of cycles per second. Yeah, I won't ramble on. But anyways, these numbers are in hertz. So theta, that's when you're just starting to wake up or when you're just falling asleep. Then you have alpha. Alpha is a resting state. You're fully alert, you're awake. However, you are very calm and relaxed. The alpha wave would be most prominent, maybe during prayer, meditation, activities like that. The next up you see here is the SMR, that's the sensory motor rhythm. And we're going to talk about that later today, later in the presentation. So I'll get to that later, because the SMR is kind of in between wave bands. It's in between the alpha and the beta. So anyways, so beta is next up, and beta is what we're in now. You're awake, you're alert, but there's no emergency. All systems are on, but like I said, no emergency. Then we have high beta. High beta waves are going to be most prominent when a client is in a state of anxiety, some type of extreme distress in reaction to a stimuli that you would be very afraid of, or that you would fight, or it could also trigger the freeze or the fawn response. So that's what EEG, it measures. When we get to QEEG, I'll talk about it more. Okay. All right. So just very briefly, because I know a lot of you probably know how neurofeedback works. And for those of you who don't, you can look it up. But so basically, just like I said before, so instead of doing a whole cap like you do when you do a quantitative electroencephalography, once you're able to target the areas of the brain that are dysregulated, then you're able to apply sensors to those areas. And then the sensors go to an amplifier. The amplifier goes to my computer. My computer has a pre-programmed protocol that's designed just for the client who's sitting in the chair. And so then the client watches a show, and the volume as well as the picture will increase or decrease. So it'll get, when your brain's doing the right thing at the right time for the right task, then you're going to get full volume, full brightness. Conversely, when your brain is not doing the right thing at the right time, then the image will fade, the volume will fade. And that's the feedback part, because everybody wants to watch their show. And so that feedback prompts the brain to change the electrical activity that's happening at that moment. And you come in and you do this over time, and you train your brain into more adaptive thought, feeling, and behavior patterns, and away from those maladaptive thought, feeling, and behavior patterns that brought you to therapy. Okay, so here's that QEEG I was talking about. This is the initial diagnostic. Everybody that comes to my office, they do a normal counseling intake. So just a biopsychosocial overview of their life and what's going on. But this gives me a snapshot of what their brain is doing in real time. When the client comes to my office, it's very calming, relaxing atmosphere. There's no need for, and also the client, and there's no stimuli. So everything's quiet. And also the client is directed to relax with some breathing exercises, as well as some visualization as to a calm, relaxing, happy place. And therefore, the brain during that time shouldn't have any need for an excess of beta, high, really no excess of any waveband. And we'll go into the QEEG more later in the webinar. And let's see. Oh, and also QEEG is good because you can do a pre and post. So you can do a QEEG pre neurofeedback therapy, and then one post or during neurofeedback therapy. And that helps to guide the treatment plan. Okay, we'll go on to the next. Okay, so today we're going to focus on attention deficit disorder, attention deficit hyperactivity disorder. Some of the common features are inattention, ability to stay still, inability to follow directions, things like this. And you can see it on the brain map. And the way that you see it on the brain map or the QEEG is that client will have a high theta to beta ratio. And what I mean by that is, so remember, delta, theta, alpha, beta. So delta is the long, slow, sleepy wave. Theta is next up. You're falling asleep or you're waking up. And so the theta wave relative to the beta wave, that theta number on top is going to be higher, whereas it should be lower. So clients that exhibit symptoms concurrent with ADHD, they can often have a high theta to beta ratio. Excess frontal beta. Frontal just means frontal lobe, and you will see on the QEEG, and actually I'm just going to refer back to it. I'll just do that. So here in this column, the beta column, if a client had excess frontal beta, you would see this right here to be higher than average. And then as for the high theta to beta ratio, this would be a lot higher than this. But I'll explain what that means later in the talk. Another thing is low alpha peak frequency. That's another common EEG deviance that is very broadly seen in clients that struggle with ADD, ADHD. Alpha peak frequency is often a marker of intelligence. And like I said, we'll get to that a little bit later, but just speaking in terms of the QEEG, because this right here, this is just a summary map. And so this is a summary of all the data, but as you go through a full quantitative electroencephalographic report, it's probably like 40, 45 pages. There's a lot more to be seen besides this summary map. And like I said, we'll get into that later, but the peak alpha frequency is going to be found here in the alpha waveband, and clients who have low peak alpha frequency often struggle with symptoms of inattention and or hyperactivity. And then the last one that we'll talk about today is the deviant sensory motor rhythm. So again, sensory motor rhythm is kind of this space here, that 12 to 15 hertz, or does it say 12 or 13? That's 13. Depending on what database you're using, some say 12, some say 15. They can vary by a hertz or two. But anyways, and so the sensory motor rhythm is located here along the sensory motor strip, and it is from 13 to 15 hertz, somewhere between the alpha and the beta bands. Okay, so those are the common deviancies that we're going to be talking about today, consistent with ADD, ADHD. So let's get into a little bit of the history. So neurofeedback's actually been around. I don't know about neurofeedback. Neurofeedback's probably been around since the 60s or the 70s, but EEG in and of itself has been around since the 1920s. And it was developed in order to detect seizure activity. But anyways, in 2000, and I think this was 2011, yes, some studies were done with rhesus monkeys, where they were asked to do a task where their eyes had to move between two fixed points. And that's what you see in row B. You see just a graphic of the monkey doing the task. And so what happened is they wanted to detect whether the area of the prefrontal cortex, the oculomotor area, if that was lighting up when the monkeys were doing the task, because they wanted to make sure that the measures were correct. And they were. So they were able to find that not only did this area of the prefrontal cortex light up, that they were able to reward the monkeys with juice when they completed the task in an appropriate way. And so after several days of the monkeys completing this task over and over again, their performance improved. And also, these monkeys received, over the course of these days, they received neurofeedback training. And so, in addition, their performance improved after neurofeedback training. And the reason why I chose this one to talk about here is because monkeys do not understand language, or at least not anywhere near the capacity to what we do. And so monkeys could not understand. They couldn't be told what the goal of the neurofeedback training was. And so they got better at this task as a result of the neurofeedback training, because how could they get so much better at it? And it's not, well, yeah, I'm just going to leave it at that. And like I say here, the results point to the possibility of conscious control over populations of neurons that were being studied. All right, next up. And so this is a study with, I think it had about 40 participants, and my references as well as my slides are available. So all you have to do is just email Emily or Morgan, and I'll be glad to provide the reference slides for anybody. who wants them. And I will say that I did have a bit of difficulty getting some of the papers just because they were behind paywalls. And so I don't have as many figures as I would have liked. So anyways, the purpose of this study was to investigate whether the alpha power. And so going back to what I said about EEG deviancies that are common to those who struggle with attention deficit disorders, one of those is low peak alpha. And so the purpose of this study was to investigate whether individual upper alpha power could improve cognitive performance. And here, this study shows that after one session of neurofeedback training, 50% of participants learned to modulate that upper alpha successfully. And that also correlated with improvement on the cognitive task. And so that is going to be shown with the bars here on the left. You see that pre-neurofeedback training, they performed around here. And then post neurofeedback training, they performed much better. I have left out. Yeah, okay. All right. So anyways, when it says alpha responders versus non-alpha responders, this study also included some theta training, but since that's not pertinent to the topic today, I chose not to focus on that. So when you see alpha responders, it just meant that their alpha frequency increased after neurofeedback training, their peak alpha frequency. And so we'll move on. Okay, now this one, I don't have any figures at all because it was behind a paywall and I just couldn't get it. But this study was conducted by David Vernon through the Imperial College of London. He was looking to investigate the potential for improvement of attentional processing by training deviancies in the sensory motor rhythm, 12 to 15 hertz here. After 8 sessions of this type of neurofeedback training, the participants improved on their performance on working memory task, as well as a go, no-go task. And those who underwent another type of neurofeedback training did not show those improvements. And so what this means is that this study really speaks to the efficacy of neurofeedback targets, of the groups of neurons, of the circuits that the neurofeedback therapy is training. And so that's why I chose this, because they trained one band, the SMR, between 12 and 15 hertz, and then they trained something else. And the ones that were trained in SMR, their performance in the cognitive processing, as well as the working memory task, did improve. And like I said, if you're interested in reading that paper for yourself, it's Vernon et al. From 2003. And I'm happy to provide the slide with references. All right. So then the theta-beta ratio. And so here on the left, we see this is EEG of someone that's diagnosed with attention deficit hyperactivity disorder versus a healthy control. And this one is the first, the delta band. We're not going to look at that now. So looking at the theta band, you can see that this is an excess, because down here, these are the standard deviations. So if you see green, that means that they're in the norm. And so the way that EEG is measured is they take the participant or the client's brainwave activity, and then they measure that against a composite of the population by age. And that's the normative database that's used. So when you're looking at this, and if you see green where it says 0, that means you're right on target with the norms. However, if you move to the right and you see that yellow, that orange, that red, that's 1, 2, 3 standard deviations above the norm, and conversely, -1, 2, 3 standard deviations below the norm. And so here you definitely see that red. So that's going to be 3 or above standard deviations of excess theta wave in the theta wave band. Then moving down to not the next, which is the alpha, but the one after that, which is the beta band, you can see that this is slightly, the color is slightly, it's more muted in comparison with the healthy control. And so that goes back to that high theta to beta ratio. Too much theta, not enough beta. Yeah. All right. So now we'll get into some circuits and some networks and some, yes. So what we're looking at here is we are looking at the reward network. Brain activity involves changes in the electromagnetic fields on which behavior depends. And according to the cognitive triangle, which I'm pretty sure most everyone here is familiar with, thoughts lead to feelings, feelings lead to behavior, and back around, vice versa, hence the bidirectional arrows in between the vertices of the cognitive triangle. So anyways, reward network refers to a group of structures that are activated by rewarding or reinforcing stimuli. So when you're exposed to a rewarding stimulus, the brain responds by increasing dopamine release. And that rewarding stimulus could be, I don't know, you won the lottery, or it could be alcohol, or it could be a maladaptive behavior, could be gambling, could be skin picking. All these things could stimulate a dopamine release if that behavior or that stimulus or that external environment, whatever's in your environment, is pleasant to you. And so when you're exposed to that rewarding stimulus, the brain responds by increasing the dopamine release. And the structures in the reward network are found along the major dopamine pathways in the brain. And this is called the mesolimbic dopamine pathway. And this pathway is posited to play a primary role in the reward system. It connects the ventral tegmental area, which is a primary dopamine producing area. It connects that VTA with the nucleus accumbens. The nucleus accumbens is an area found in the ventral striatum, and that is strongly associated with motivation and reward. And so and then there's just a couple bullet points down here that I won't read over because I'm sure you all can read those. But what happens is that those that struggle with attention deficit disorders, their reward pathways are altered somehow. They don't function quite right. And the wrong way. Okay. I'm not sure why that's here. I'm sorry. I'm out of order. I'm out of order and I'm missing a slide. There it is. Okay. So keep going on talking about that mesolimbic dopamine pathway. This is just another picture of the same thing. But I like this one. I like them both, so that's why I included them both. Because I like to look at the bullet points, you know, what the functions are: reward, pleasure, compulsion, perseveration. And then again, This one highlights also the serotonin pathways. And so serotonin helps to fine tune that dopamine release. And so just like I was saying before, rewarding stimulus, increased dopamine release. Okay, so now we'll go ahead and get back to the the QEEG. So what we're getting ready to look at is we're going to look at a case study from an actual client of mine. And so in order for me to really discuss this client and the case, it's going to be necessary for you to know a little bit more about quantitative electroencephalography, otherwise known as a brain map. Really for this talk, I'm going to focus on the top row. The top row, that is a measure of absolute power. And what absolute power means is that for each one of the 19 sites that I'm measuring, it's the actual power, it's the actual electrical energy that is emanating from that area. And so that's the row that we use when we're looking for that high theta beta ratio. The alpha peak is a different page of the QEEG, but we'll talk about that later. And so yeah, this is what a typical brain map looks like. And so what you would do with the client is first you would conduct the initial intake, which I said is just like a biopsychosocial of their history, their life, and then you talk about the presenting concerns and what brought them to therapy. And then the second step is to take this quantitative electroencephalography so you can get a snapshot of the brain's electrical activity. All right, so the client that I'm going to talk about today is a 7-year-old little boy. And I started working with him, gosh, I don't know, somebody else did his Q before I got here. But I started working with him probably in like April. So he had only been doing neurofeedback therapy maybe a month or two before I started working with him. And so when I met him, he could not sit still. He could not sit still. An arm was moving, a leg was moving, his head was moving. He would ask like and I would document all this during neurofeedback therapy. He'd ask maybe every 5 minutes or so when it was going to be over. And he was watching a show. I can't remember what cartoon he liked to watch, but he used to watch some cartoon. And even though he really liked the cartoon, it was only able to hold his interest for a couple minutes at a time. And so, like I said, his diagnosis is ADHD, combined presentation. Another issue that he was dealing with was his little arms and his legs were just marked. He would pick himself bloody. It was a body-focused, repetitive behavior. And he just could not control it. Thankfully, he didn't pick during session. Parents told me that really he did most of his picking at home. He knew that it was bad and he knew that it was wrong, but he just couldn't, and he was able to stop himself from doing it in public. But when he was at home, the picking was really out of control. Parents told me that they used to wrap him in gauze before going to bed, just because he bloodied so many sheets and so many bedclothes. And so those are the presenting concerns. Just couldn't stay focused. If they would ask him to do something, he would be doing something else unless they were there to monitor him through it step by step by step. Obviously, he was getting in trouble at school for not staying in his seat. Again, couldn't follow directions, and also understanding and respecting the personal boundaries of others. He was notorious for, he had two older sisters, and he was notorious for bursting in their room. He would grab the things off their shelves, wanting to play with their things. And he was just, his little brain was just going so fast, 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 fast all the time. He could not slow enough or process the information that was being given to him, AKA directions from parents. You know, you have to respect your sister's things. He just couldn't do it. So this is the client's first QEEG. Yep, it was done February 2nd. And so yes, that was probably about 2 months before I started working with him. And this is right before the onset of the pandemic. And so he switched from in-person class to, by the time he got to me, he was being homeschooled. And so we can see here, and these are the three things that I want to look at here, are the theta-beta ratio. So you see here that he does have some excess theta. However, when you look at the beta, he also has excess beta there as well. And so one of the training methods that I used with him was a protocol to increase theta power and decrease beta power, because although both of these wave bands are in excess, when you look at the actual numbers, the ratio is too high for normal brain function. Then you can also see he does have an excess of frontal beta, as well as that sensory motor rhythm. So that's not exactly, so we use QEEG Pro. That is the name of the processing software that we send our raw data to send us back these brain maps. And so that sensory motor rhythm, that 12 or 13 to 15 hertz, it's not delineated here, but that's what it is. And so what we're looking for is, we're looking for a normal electrical output when it comes to the 12 or 13 to 15 hertz along the sensory motor strip. And also another thing, looking at these brain maps, if you are it would almost be like you were looking, just like the same way you do in a neurofeedback session, or when you're hooking up the client for neurofeedback, it's like you're looking down at their head. And so you can, I don't know if this has like the two little circles on the side, and then there's like a little triangle for the nose. And so these dots here in the middle, that represents the sites here, 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 and here. And that is the sensory motor strip of the brain. Okay, so that's that. So, and also he's got a bunch of other stuff going on, but this is not really the focus of my talk today. But just very quickly, the asymmetry, that's the balance of the brain, and then coherence is the quality of the signal, and then phase is the speed of the signal. And as far as those metrics go, when you see red, it means it's too fast, and when you see blue, it means it's too slow. So all these red and blue lines that you see here signify abnormal function, abnormal brain functioning, because what we are is electricity and chemicals, and neurofeedback works with the electricity of the brain, and then the chemical function follows, and vice versa. So that's what happens with drugs. When you give someone a drug, it changes the chemicals in their brain and therefore their body. And those chemical changes also elicit electrophysiological changes. But the difference, well, one difference between neurofeedback therapy and medication is that for most drugs, when the drug is in your system, it works and you feel better. But if you forget a day or you stop taking the drug, then the dysfunction comes back. With neurofeedback therapy, these changes are long lasting, because what you're doing is you're taking those maladaptive thought, feeling, and behavior patterns, and you're changing those. You're starting to change those into more adaptive thought, feeling, and behavior patterns. And so once you change those, the effects are usually long lasting because, well, in part because you begin to seek rewards in other ways. You're not seeking the reward from, I don't know, from the drinking or from the drugs or from the gambling or whatever maladaptive behavior pattern you had. That's no longer giving you the reward. It's staying in your seat. It's paying attention. It's more adaptive. Okay. So then this is one of, so remember how I was talking about when you get that initial QEEG, it's like a 45-page document. So this is just the head map. This is just the summary. But as you start to get into more of the QEEG, then you start to see each of the, they call it by bin. So you can see what your brain's doing at 1 hertz, 2 hertz, 3 hertz, all the way up until, I think it goes up to 30 something. But really, I just kept to 20 because that's what we're talking about here today. But you can get in there and you can see this is where that high frontal theta to beta ratio, it really shows up. And again, just to remind, oh, shoot. I transposed my numbers. So please disregard this. 4 to 8 hertz is the theta band and 13 to 20 hertz is the beta band. So that should be reversed. So mistake. Everybody makes mistakes. But anyways, he does have a very high frontal theta to beta ratio. And so then here's another page of that QEEG. And this shows that low alpha peak frequency. And so again, it's the same color coding system for the Z-score summary that we were looking at before. And you see here that teal blue color indicates deficiency in alpha, which is also another hallmark of an EEG of someone who struggles with attention deficit disorder. And so then here's his second QEEG. So this is in August and he started training in February. So, so that's about 6 months later. This client was coming in usually about twice a week. And so after all those sessions, he really cleared up. You can see down here with the asymmetry and the coherence and the face, lot less red, lot less blue. I mean, a lot. And over time, and that's just to give you kind of a refresher, you know, so that's what we started with. And then this is where we ended up. And what I saw with this client was it seemed as if probably after the first, I don't know, 15 to 20 sessions, he was sitting still. He was watching the show the whole entire time. He would no longer ask me, how many more minutes? When is this going to be over? Can we watch something else? And so that was one of the changes that I first started to notice. Also, parents reported that prior to the onset of neurofeedback therapy, that this client would have on average anywhere between 3 and 10 emotional outbursts per day. And when I say emotional outbursts, that means that this child would throw himself on the floor and scream and cry. If he passed by McDonald's and was told, no, you can't, we're not going to get McDonald's, he would throw an out and out fit. And also the picking got better and better and better. And I noticed, Well, when he would come in, he had long sleeves. I mean, it was winter time. So sometimes I would ask to see his arms, but sometimes I wouldn't. But by the time it was warm enough to be summertime, I mean, I could see the little dots on his arms. They weren't bloody anymore. They weren't bleeding anymore. They were dry. And parents were reporting that the picking slowed down, and eventually, finally, the picking stopped. Another thing is that prior to neurofeedback therapy, he wasn't really able to participate in school because he just had so many emotional outbursts, and he just wasn't able to stay in his seat. He wasn't able to stop talking. And he did go to school online because of the pandemic. However, parents reported that he was able to complete multi-step tasks, that they could leave him alone in front of the computer screen, and that he would sit there and listen to the teacher and follow her direction and complete assignments on his own. And so, yeah, so this is the result of about 6 months of neurofeedback therapy. That's what his final QEEG looked like. And so I love this picture. This is my favorite. So this picture was drawn by the client that I'm talking about. It was probably about halfway in to our time together in neurofeedback therapy. And one day I was having technical difficulties, and he was still pretty hyperactive. I mean, he was still, moving around and asking questions and talking a lot and stuff like that. But I needed to focus because I needed to get my equipment correct so that I could run his session. And so when he just wouldn't stop talking and wouldn't stop talking, I just gave him a paper and a crayon. And I was like, here, just draw something. I was able to fix my equipment. And once I fixed it, he showed me the drawing. And I asked him, I was like, client, I said, what's this? And he said that the large figure was me and that the little one was him. And that was his interpretation of the neurofeedback therapy. And what I was looking at on my screen was those numbers. And it was really striking to me that he drew me with a big smiley face. It made me feel really good and really good about the work that I'm doing here and the work that I was doing with him, because it looks like he felt good about it too. So there is my slide of references, and that's the end of my talk. And so it is just after the hour, and so now we can start any question and answers.
Thank you so much. That was wonderful. Let me pull up. Hold on. Thank you. I apologize again for the disruption at the beginning. We did have a few questions in the chat too that I want to make sure that we address. We had seen, Laura had asked about internal stimulation. Laura, do you remember more about that question in context? I think it was
Yes. When Carmen was describing those states, and I don't remember which one now, but I think it may be the second one. Let's see here. Let's see, go
theta?
Yeah, and where it's you were describing, for example, the conditions in your office, and how you're externally there's no stimulation stuff. And I was just wondering about what if they brought stuff internally in their thoughts. I mean, I can imagine a lot of kids would be scared to death. I don't know. Or just if they have high anxiety, stuff like that.
Yes. Great question. Thank you for bringing this up. And so, oh my gosh, it's true. They bring in all their stuff, all that mental stuff, all that perseveration and the worry and the fear. And sometimes for people, it's depression, it's rumination, it's the partner, it's that trauma too. They do bring it in. And what happens, the way that we do it is that we want to try and help the client calm as much as possible. However, I've got 90 minutes. I've got 90 minutes and that's it. So you have to do it within a certain amount of time. And what you want is the best snapshot of their brain and what their brain is doing at that moment in time. And so, yeah, they do bring all that stuff in. And so what I do is I talk with them beforehand. I talk to them about what neurofeedback is. And I do that during the intake. And then I go over it briefly when they come into because I'm still doing intakes online because of COVID. So anyways, I'll show them like my equipment. I'll show them some of the wires. I'll show them the cap and prepare them that way. And then because once you put that cap on, you've got to put gel in each of those 19 sites. And then you've got to like move the hair around and make sure that it's a good connection. I mean, it's a process, it's involved. So I usually let the client watch some kind of show or listen to something that's calming and relaxing